In the next section on limits, we are going to learn how to read one-sided limits involving vertical and horizontal asymptotes. Limits at infinity. If we take a look at the rational function 1 over x plus 2, if I was to approach or ask what's the limit as x approaches infinity of this graph? Well, as x approaches infinity, okay, that means x is going further and further to the right. And if we look at the graph, as it goes further and further to the right, it gets closer and closer to the x-axis, but doesn't touch, but it's getting closer and closer to 0. So the limit as x approaches infinity would be considered 0. Similarly, the limit as x goes to negative infinity, so that means to the far left, the graph gets closer and closer to the to the x-axis, which is going to be 0 again. In the next example, we have the limit as x approaches infinity. And the limit as x approaches infinity, you'll see that the graph is approaching a horizontal line of 3. And as x goes to negative infinity, the graph is approaching the horizontal line of 0. So in these two examples, you can see that the limit as x approaches infinity and negative infinity really are our horizontal asymptotes. And we are used to most graphs having one horizontal asymptote, like in this example here. Occasionally, you might have a graph that has two horizontal asymptotes, one to the right and one to the left. So the line y equals b is a horizontal asymptote of a function if the limit as x approaches infinity of the function equals some number, or the limit as x approaches negative infinity of a function equals some number. Now let's go back to our original function. If we were to look at this graph again, and I asked you what would be the limit as x approaches -2 from the positive side. Well, here's -2, the vertical asymptote. As I approach -2 from the positive side, the graph is going up and up and up. It's going towards infinity. As I approach -2 from the left-hand side, the graph is going down and down and down towards negative infinity. So when the answer is infinity or negative infinity of a one-sided limit, there's a good opportunity that that is going to be a vertical asymptote. So if we take a look at this next question, okay, we have the limit as x approaches -2 from the left, would be negative infinity. The limit as x approaches -2 from the right would be considered positive infinity, and therefore the limit as x approaches -2 does not exist. Why? Because the limit from the left and the limit from the right aren't the same. Now, some textbooks will just say right away that this limit does not exist as it approaches infinity, because infinity is not really a bound number. So sometimes some textbooks will say it does not exist. Sometimes they'll say it's going towards infinity. Our textbook, the Calc 30 textbook, uses a notation of this is going to infinity, this is going to negative infinity, and the limit at -2 does not exist. All right, what appears to be the value of the limit as x approaches -4 from the positive side? Well, if I approach -4 from the positive side, the graph tends to be going up towards positive infinity. As I approach -4 from the, -4 from the positive side here, the graph tends to be approaching a value of 1. I would like you to pause the video and give this question a try. Okay, taking a look at our answers, the limit as x approaches 0. Well, as x goes to 0 from the left and the right, the graph is approaching 0. The limit as x approaches -1 from the left is going up towards positive infinity. -1 from the right, it's going to negative infinity. Therefore, the limit as x approaches -1 does not exist. The limit as x approaches infinity, as x goes to infinity, it's going further and further to the right, and it's approaching 1. And as it goes to negative infinity, the graph is going again towards the horizontal line of 1. Okay, let's do this one together. Okay, so we have the graph j of x, and j of x graph is shown. The limit as x approaches -1 from the positive side is infinity. As x approaches -1 from the negative side, it's infinity. So our textbooks will say that the limit as x approaches -1 is infinity because they're both going to positive infinity. As I approach 1 from the right, it's going towards infinity. As I approach 1 from the left, it's going to negative infinity. and therefore the limit as x approaches 1, according to our textbook's definition, would be does not exist. The limit as x approaches infinity, so as x goes further and further to the right, the graph is going to -1. As x goes further and further to the left, the graph is also going to -1. All right, so the line x equals 0 is a vertical asymptote of a function if the limit as x approaches a from the positive side is plus or minus infinity, or the limit as x approaches a from the negative side is plus or minus infinity. We kind of talked about that earlier, but we never did give you the formal definition, but there you go right now. Now we're going to look at sketching graphs that involve certain conditions. So say we're given the following graph, and we want to graph draw a picture of a function that has all of this information here, okay? And if we look at the question, it says we want to sketch this and use dotted lines on vertical and horizontal asymptotes, okay? So let's start off, first of all, with f of 0. Again, these don't have to be done in any particular order, but all these conditions have to be met. F of 0 is 2. That just means when x is 0, y is 2. So that's a point on the graph, okay? We also know the limit as x approaches 1 is 3. So that means as x is 1, the y value is going to be approaching 3. And again, that could be a defined point. So I'm going to just treat it as a defined point. You could put it as an open circle, but the graph has to go there through that point. Okay, the limit as x approaches 2 from the negative side is infinity, and the limit as x approaches 2 from the positive side is negative infinity. That means that the line x equals -2 would have to be a vertical asymptote. And we know it says in the question, coming from the left of -2, it's going up, and coming from the right of -2, it's going down. Okay, so we've got rid of these two. Okay, are there any other vertical asymptotes? Well, it appears the limit as x approaches 6 from the left is infinity, and 6 from the right is also infinity. So that would indicate that 6 is also a vertical asymptote. Okay, and again, from the left and from the right, they're both going to infinity. So that means it's going up there, and it's going up there. Okay, so I've gotten rid of these two. I have another point here. F of 4 is 0. So when x is 4, y is 0. Okay, so I've gotten rid of that. And all we really have left is, whoop, I took one off that I shouldn't have, this guy here. Okay. So first of all, I have the two limits involving approaching infinity. Those are my horizontal asymptotes. So going to the right, the limit as x approaches infinity is 1. So that means I have a horizontal asymptote of 1 this way. And I just put that on the furthest right section of my graph, okay? And as I approach negative infinity, the graph is going towards a horizontal asymptote of 0. So now when I sketch this graph in, this guy is going to come down, and he's going to be bounded by the horizontal asymptote. This guy is coming down. He's going to pick up this point here, and he's going to continue down that way. And this graph is going to come down, pick up these 2 points, and curl towards the asymptote line there. So there would be a graph of your function incorporating all of these conditions. Okay, so there is your assignment for today. Okay, give those a whirl, and we'll continue with limits the next lesson.